What's up, everybody? My name is Dana Harris with Young Gurus Math Tutoring, and I'm back again to drop some more math jewels. In this video, I ain't got no notes. My notes over there. How I'm supposed to show you any math jewels if I ain't got no notes? I'll be back. Alright, now that I'm back, I can show y'all some math jewels. Today in this video, I'm going to be showing you how to use long division of polynomials. Now, this is a topic that's crazy. They still teach it in college algebra classes. Some high school algebra 2 classes teach it as well, but I'm going to teach it to you anyway because I just want to teach it. So let's get right into the example. When we think about long division of polynomials is just like regular long division. Only difference is you're dividing a polynomial or a polynomial by a binomial. So first example, 25n to the third power minus 11n plus 4. And we're going to divide that by the binomial 5n plus 4. Okay, now watch this. I'm going to rewrite it so it looks like regular division. So I have 25n to the third power. Now notice I don't have a n squared term, so I have to put 0 n squared. That is one of your rules. Minus 11n, let's extend that, and then plus 4. Okay, I'll put my divisor on the outside, 5n plus 4. Now you're going to have to follow along very closely. Please rewind, stop, and all that good stuff. So I need to first of all see how many times can 5 go into 25. So 5n, how many times can it go into 25n cubed? Well, it can go 5n squared times. Okay, and I'm going to prove that down here. So just like regular long division, you see how many times the divisor can go into the first term in the dividend, and then you multiply. So now I need to multiply 5n plus 4 times 5n squared. So that's going to give me 25n cubed, and I should get the same thing down here. And then 4 times 5n squared gives me 20n squared. Notice I put the subtraction on the outside. That's up to you. Some people do this different ways, but I like to just distribute this subtraction. So 25n to the third power minus 25n to the third power, that'll be 0. And then 0n squared minus 20n squared is negative 20n squared. So we can actually get rid of this 0. You don't necessarily have to put that there as a placeholder. Then I need to see how many times can 5n go into 20n squared. Well, it can go in, it's a negative, so 4n times, okay? Once again, I still need to bring down this 11n. I'm sorry about doing that. And then I multiply again. 5n times negative 4n is negative 20n squared. 4 times negative 4n is negative 16n. Negative 20n squared. Remember, when I subtract a negative, that's the same thing as adding. So negative 20n squared minus negative 20n squared, that gives me 0. And then negative 11n minus negative 16n. Whenever you subtract a negative, it's just like adding. So negative 11n plus 16n is going to give me 5n. I bring down my plus 4. 5n plus 4 goes into 5n plus 4 just one time. Okay? And so when we do this, 5n plus 4, it'll have 0. So our quotient actually is 5n squared minus 4n plus 1. Okay? And just like regular long division, you can actually take this quotient and multiply it by the divisor. And if you multiply them together, you should get this dividend. All right, that's one example. Let's look at another example. I'm going to erase all this good stuff. All right. Now, these are rather long, like I say, but the process is really just like long division. It's just that you have to be very, very careful, very tedious with your work on these. So example 2, we have 3b cubed minus 10b squared plus 4. All right, and we're going to divide that by 3b minus 1, or tree b minus 1. All right, same process. I'm going to write it just like regular long division. So I'm going to put tree b cubed minus 10b squared plus 4. Also make sure in this case actually I almost did what I was just about to tell you not to do. Okay, so we don't have a b to the first power, so we have to put 0b to the first power and then plus 4. Okay, you always have to put that placeholder in and write your exponents, or write your exponents in descending order. So if there's not a term with that exponent, you have to fill it in. Okay, let's put our tree b minus 1 up here. Tree b goes into tree b cubed, b squared times. Okay, and then we're going to multiply. 3b times b squared is going to be 3b cubed. Negative 1 times b squared is minus b squared. We subtract 3b to the third power minus 3b to the third power gives you 0. Negative 10b squared minus negative b squared, so that's actually negative 10b squared plus b squared. It gives you negative 9b squared. We bring down our 0b. All right, tree b goes into negative 9b squared negative 3 times. Actually, negative 3b. Okay, same thing, multiply 3b times negative 3b is negative 9b squared. And then negative 1 times negative 3b gives you plus tree b. All right, I got to look at y'all when I'm doing this because I don't want y'all to think I'm your professor that just teaches himself on the board and stuff like that. So, subtraction. Remember, negative 9 minus negative 9b squared minus negative 9b squared gives you 0. And then if I have 0b squared minus 3b, that gives me negative tree b. I bring down my plus 4. Tree b goes into negative tree b negative 1 times. We subtract. 3b times negative 1 is negative 3b. And negative 1 times negative 1 is positive 1. When I subtract, negative 3b minus negative 3b is 0. 4 minus 1 is 3. Now, in this case, this 3 is a remainder. So you have to write this one a little different. So we say our quotient is b squared minus 3b minus 1. And then plus, watch how you write the remainder. We take this remainder of 3 and then we put it over the divisor. So 3b minus 1. So notice you write your regular quotient, but then the remainder is a fraction over the divisor. Okay, be very, very careful with that. All right, so that's long division. Y'all want me to do one more? I'm gonna do one more. Let me do one more, just to make sure y'all got it. This one I want to do because sometimes, you know, when you're given, a lot of people complain that, you know, their instructor gives them problems that look different from the problems that are on their actual exam. And especially if you're a college algebra student out there watching this, they really deal with that. And so I want to give you one like this. Example tree. I said I'm going to start talking proper English, but I'm still going to say tree. And if you haven't seen why I say the number tree instead of 3, please go watch my video called The Number Tree. So watch how this one is written. Okay? And my divisor is 3 plus 5a. Notice these are not written in descending order. Okay? So when I rewrite this under the radical, I need to start with the 15a squared. And then there's minus 16a, but then minus 15. So my exponents are in descending order. I need to put the divisor correctly, so I need to say 5 a, and then plus tree. All right. So now same process. 5a goes into 15a squared 3a times. We multiply. 5a times 3a is 15a squared. 3a times 3a is minus 9a. We subtract all this. 15a squared minus 15a squared equals 0. And then negative 16 minus negative 9 is the same thing as negative 16 plus 9. So negative 16 plus 9 is negative, what is it? Actually, you know what? This is wrong. This should be plus. All right, so negative 16 minus 9 is negative 25. I knew something was looking fishy over there. Okay, that's why I keep notes when I'm doing this. All right, so now 5a goes into 25a, or negative 25a. We know it's negative 5 times, and then we simply do our subtraction. 5a times negative 5a is negative 25a. And then 3 times negative 5 is negative 15. Notice I have the same thing here as in parentheses, so there's no remainder on that. So your quotient is just 3a minus 5. Okay? So if I have this polynomial divided by this polynomial or binomial, trinomial divided by a binomial, I'm going to get this quotient. Young Gurus Math Tutoring, I got the solution to your math problems.